So we are moving on to section 7.2. We're still on exponents, but this time we did rules 1, 2, and 3 on 7.1, and right here on 7.2 we're doing rules 5, 6, and 7. I know you're thinking, wait a minute, what happened to rule 4, right? We did 1, 2, and 3 on 7.1, and right here we're doing 5, 6, and 7. What happened to rule 4? Well, the truth is rule 3 from the last video is the same thing as rule 4. The only difference is that rule 4 in our class is where we have fractions on the inside. So if you remember rule 3, it says if you have parentheses with an exponent on the outside, kind of like this. See, there's parentheses right there. There's an exponent on the outside. And a monomial on the inside. What do I mean by monomial? No addition or subtraction. It's very important to note that we don't want any addition or subtraction on the inside of the parentheses. So it can't be 2 plus x squared. It can't be x squared minus y. There's no addition or subtraction. It's all pure multiplication. So then we are able to distribute the exponent from the outside to each inside exponent. And remember, power to a power, you multiply. So we first recognize that there's an invisible exponent on the 2. There's invisible 1 on the exponent of the y. We're going to take the 3 and multiply it times that 1, and 3 times 2 and 3 times 1. And we'll get our new answer, 2 to the third, x to the sixth, and y to the third. Now some of us think, oh, we're done. But the truth is we could still simplify further. The 2 to the third is 2 times 2 times 2, which is really 2 times 2 is 4, and 4 times 2 is 8. So 8x to the sixth, y to the third is your final answer for that particular example. Now that was rule 3. Now like I said, rule 4 is the same thing. The only different type of problem you're going to have is something like this. So it's the same exact rule. You still have parentheses right here. You still have an exponent on the outside, and there still is a monomial on the inside. There's no addition or subtraction, right? There's multiplication between the x squared and the y to the third. There's multiplication between the 2 and the z. So it's the same exact rule. All you have to do is distribute the outside exponent into each and every exponent on the inside and make sure you multiply. Because of rule 2, a power to a power, you multiply. So again, the 2 has a 1 and the z has a 1. So let's distribute this exponent of 3. And 3 times 2 is 6. So on our answer, we're going to get x to the sixth. 3 times 3 on the y is 9. So on our answer, we're going to get y to the ninth. And on the bottom, when you distribute 3 to the 1, or you multiply 3 times 1 is 3. So you get 2 to the third. And again, distribute the 3 to the z. So 1 times 3 is 3. So you get z to the third also down here. So this is the answer. The only other thing you could do is change your 2 to the third to 2 times 2 times 2, which is 8. So if you put an 8 right there instead of the 2 to the third, that would be your final answer. And that is rule 4. So we're kind of like skipping rule 4 because rule 3 is rule 4. So hopefully we already understand that we need to distribute the outside exponent to each and every term on the inside. Let's move on to actual the rule number 5. I love this rule. Rule 5. Anything to the power of 0 equals 1. That's right. Let's look at an example. X to the 0, the answer is 1. How about y to the 0? The answer is 1. How about 1,352 to the power of 0? If you did that on a calculator, the answer is 1. Anything to the power of 0 equals 1. I love it, right? How about this? How about, let me erase this. How about 59 to the power of 0? That equals 1. How about a happy face to the power of 0? That equals 1. Yeah. Okay, so anything to the power of 0 equals 1. Do we understand that? Yep. Anything. So if you think you understand that, write this one down. 2x to the power of 0. That equals
1.
2. What? It's just 2. Okay, so once again, I think we all understand this, that anything to the power of 0 equals 1. Now let me ask you this. When you look at the term 2x to the 0 power, what has the power of 0? The x has the power of 0. Does the 2 have the power of 0? No. It has a power of 1, right? So the only thing that has a power of 0 is the x, so that becomes 1. And that 2 that's in the front just comes down, and you have to multiply 2 times 1. That's how you get 2. So that's the only curveball. All right? That's the only curveball that this rule could throw at you. Let's ask you a couple more here. How about 3? Y to the power of 0? 3. There you go. You guys got it. This one is really tricky. How about 3? How about negative 3 to the power of 0? That technically, negative 1. Now, why is that? Because 3 to the 0, you have to do exponents first, right? 3 to the 0 is 1, but you have a negative. So this is 1, but this negative sign's out in front of it, so that's negative 1. Now let's compare that. Let's compare that original negative 3 to the 0 with negative 3 in parentheses to the 0. The top one is negative 1. The bottom one is positive 1. You guys get it? So anything to the power of 0 is 1. Check this out. Let's write 2x to the 0, y to the 5th, z to the 0. Okay? Remember, anything to the power of 0 is 1. So what has the power of 0? Only the x and only the z. So you know that x to the 0 is really 1. You know that y to the 0 is really 1. So you could rewrite this as 2 times 1 times y to the 5th times 1. But that's a waste of time. You could just do this. Scratch it out, scratch it out. There's your answer, 2y to the 5th. So like always, parentheses do make a difference. If you have something like something pretty crazy, like let's say parenthesis 2x to the 5th, y to the 7th, z to the 13th, all to the 0 power, what's your answer? 1. Right there, it really does have everything to the 0 power, it equals 1. Okay? So, but if you don't have parentheses, then you got to look specifically for what does have a power of 0 and only change those to 1. Right here, x to the 0 is 1, z to the 0 is 1. What do you have left over? 2y to the 5th, so that's your answer. But down here, everything is included inside the parentheses. It's all to the 0 power, it's all equal to 1. If you wanted to apply rule 3 from last week, you could also do that. You could take this power of 0 and multiply it times the 1 right here. That'll give you a 2 to the 0, which is 1. Multiply it by 5, it'll be x to the 0, which is 1. It'll be 0, which becomes 1. It'll be 0, which becomes 1. So the whole thing becomes 1. But it's simple. If everything's inside the parentheses to the power of 0, the answer is 1. X to the 2nd over y to the 0 z. What's the answer going to be? X to the 2nd over z. The only thing that has a power of 0 is y to the 0, which cancels out. So there's your answer, x to the 2nd over z. Rule 6. Anything with a negative exponent must be moved from one side of the fraction to the other, from the numerator to the denominator or from the denominator to the numerator. In other words, what I'm trying to say is from the bottom to the top or the top to the bottom. So wherever you have a negative exponent, you have to move it to the other side, and then after you moved it, the exponent becomes positive. And something important to note, just like the other rule, you cannot apply the rule if you're adding or subtracting. Kind of like the rule 3 and 4. If you're adding or subtracting, you can't distribute the outside exponent. Right here, if you're adding or subtracting, you can't really move the negative exponent from one side to another. So let's start with something really basic. Right here on this example, we have x to the 3rd. Actually, let's make this x to the negative 3, all right? That way we actually have a negative exponent. Sorry about that. X to the negative 3, y to the 5th over z, okay? So that is a fraction. And it says we cannot apply the rule if we're adding or subtracting, but of course, we are not adding or subtracting. There's multiplication between the x and the y. There's division between these two terms and the z. So there is no adding or subtracting, so we can go forth with this rule, rule 6. And it says anything with a negative exponent must be moved from one side of the fraction to the other. So what has a negative exponent? Does a y have a negative exponent? Absolutely not. Does a z have a negative exponent? Absolutely not. The x has an exponent of negative 3. So what I like to do, I like to circle and draw arrows. I'm going to take this x to the negative 3 and I'm going to move it down to the other side. That's what the rule says. Okay, so what I have now, the y to the fifth is still up there, the z is still down there, but now that x to the negative 3, I moved it down and it becomes x to the positive 3. And that's it. That's rule 6. A very easy rule to remember, a very easy rule to use and apply. Again, you do not want negative exponents. Wherever you have a negative exponent, like right here we had one, you grab it, move it to the other side, it becomes positive. That's your final answer right there. Let's try another one. Right here we have 2y to the third as a numerator and x to the negative 5 on the denominator. So what we're going to do is simply take that x to the negative 5 and move it up, and it's going to become x to the positive 5. Now notice that I'm drawing an arrow between the 2 and the y because you want to set it up in alphabetical order, x, y, and a z at the end if you have a z. So right here my answer would be, well, if you want to leave the fraction bar for a while, that's fine, but there's going to be nothing left down here. You could put a 1 if you want, but that's kind of pointless. Your answer is 2, and the x to the negative 5 that moved up became x to the positive 5, and we still have that y to the third up there. So your final answer is that 2x to the fifth, y to the third. And that's it. You don't have to put it over 1. Let's look at another. Here's another curveball that some students mess up with. The answer here is 2 over x to the third. I know you're thinking, wait a minute, this has a negative exponent. All of this should go down to the bottom. But it's this simple, guys. The only thing with the negative exponent, once again, is the x. The 2 actually has an invisible 1 right there. So you need to take the x and move it down to the other side of the fraction. Now you're also probably thinking, wait a minute, there is no fraction. Yeah, all terms, you can make them look like fractions by putting a 1 down here. So you're going to bring this down and it's going to become positive x to the third on the bottom. You don't need to write the 1 in front right there. I mean, you could if you want, but you don't have to. So your answer is simply 2 over x to the third. Let's do another example. So on this one, it's kind of like the other one where we had 2x to the negative 3, but right here the 2x is inside the parentheses, right? So this whole thing has a negative exponent, so you could move down the whole thing. So you could make it look like a fraction, and you could take this whole thing and move it down, and what would we have left on the bottom? We'd have the parenthesis 2x, and on the outside you'd have a positive 3, right? And what would we have left up on top? Nothing, so you'd put a 1 up there. And on the bottom, we'd have to still apply rule 3 from last week where you have parentheses with an exponent on the outside. So we'd have to distribute the outside 3 and multiply it by the 1 on the 2 and the 1 on the x. So that would be 2 to the third, x to the third. And 2 to the third really is 8, so your final answer would be 1 over 8x to the third power. 1 over 8x to the third power. Now, this could have been approached a different way. Maybe instead of applying rule 6, where we take that negative exponent and move it down, instead of applying rule 6 first, we could have applied rule 3 from last week and distributed the negative exponent first and then apply rule 6. So it depends. When you're faced with different rules, you get to pick and choose which path you want to go down first, right? So you could distribute and then move the negatives to the other side, or you could move it first and then distribute. So right here we moved it to the other side, then we distributed. Let me go back and do it the other way. So here's the same exact question, but I'm going to distribute first. Distribute. You will have 2 to the negative 3, x to the negative 3. Then you could apply the rule with negative exponents. Oh, this one's going to go down, and this one's also going to go down. So there's nothing left up on top. You have a 2 to the third on the bottom. You have an x to the third on the bottom. So you'll get the same exact answer, 1 over 8x to the third. It's just done a different way. So it depends. Do you want to apply rule 6 first and then rule 3? Or do you want to apply rule 3 and then rule 6? Is this making sense to you guys? Yeah? Here's the last example I'm doing with rule 6 with negative exponents. I lied. I'll probably do another one. But anyway, right here we have a lot of negative exponents, and we know that anything with a negative exponent must be moved from one side of the fraction to the other. So does the 3 have a negative exponent? No. The a does, the d does not, the 2 does not, the b does have a negative exponent, and the c does have a negative exponent. So it's important that you guys move only the ones with the negative exponent. So what you should do is first start your new fraction. And what I like to do is rewrite what is not moving. So what is not moving? The 3 is not moving. The 2 on the bottom is not moving. The d up here is not moving. Okay? And the a does move. Everything else moves, right? So that's what I would do first. And then I would start circling and drawing arrows. So this a to the negative 4 is going to move down right next to the 2. And it's going to become a to the positive 4. Are you with me? This b to the negative 3, I'm going to move it up. And it's going to become b to the positive 3. Yay? And then that c to the negative 1, that's also a negative exponent, I am going to move it up. And again, I'm going to squeeze it in right here before the d because I want it in alphabetical order. And it's going to become c to the positive 1. So there's my actual final answer. Let me do it all in the same color so it doesn't look weird. 3b to the third cd over 2a to the fourth. And that's a lot of moving, right? You're moving a lot of things. There were 3 items that had negative exponents. Only those 3 items moved. Everything else stayed exactly where they were. And of course, you want to make the variables be in alphabetical order if you have multiple variables like this. Sound good? All right. Let me do one more with Rule 6, but it has a combination with Rule 1. Check it out. Super easy. X to the second over x to the negative 3. What has a negative exponent? The x to the negative 3 has a negative exponent. So I circle it. I draw an arrow. Am I moving the x squared down? No, it's positive exponent. I don't mess with it. Only the negative exponents move from one side to the other. So again, I'm going to start by rewriting. The x squared is not going to move. The x to the negative 3, it goes up and it becomes x to the positive 3. And since there's nothing left on the bottom, I'm going to put an invisible 1. And as a matter of fact, since it's over 1, you don't even need to write it as a fraction anymore. It's just really, let me just scratch it out. It's just really x to the second times x to the third. And now we have to apply Rule 1 from last week. What is x to the second times x to the third? X to the fifth. And there's your final answer on this particular example. So let's move on to Rule 7. Copy it down, please. So on this one, the answer will be 1 over x squared. Okay. Now here's the actual, bless you, the actual explanation. X to the third is really x times x times x. And it's over x to the fifth, which is x times x times x times x times x. Now we're not going to be doing this all the time. This is just to show you how the rule actually works. Whenever you divide, like if you say 3 divided by 3, what's the answer? 1. What's 5 divided by 5? What's negative 7 divided by negative 7? 1, right? It's always 1. It always cancels out. So when I say x divided by x, that's 1. It cancels out, cancels out, cancels out. So what's left up on top? Nothing. So you put a 1 up there. What's left on the bottom? There's a x times x, which is not 2x, but it's actually x to the second power. So the answer there is 1 over x squared. Make sense? Now, right here we expanded. X to the third became x times x times x. X to the fifth, I wrote the x 5 times. Again, you do not have to do this. It really becomes a subtracting problem on exponents. So like right here, oh, there's 3 up here, there's 5 down here, 3 cancel with 3. So it's really 5 take away 3 is 2, and there's 2 left over. Where are they left over? They're left over on the bottom. So that's how you know there's nothing left up on top, and there's 2 left over on the bottom, so your answer is 1 over x squared. Let's try a different one. So here's another example. You want to cancel out the terms on the numerator and the denominator that are alike. Cancel out the like terms. So like x to the third, there's really 3 x's up on top. There's 7 x's on the bottom. You're going to be able to cancel. One thing I should mention, again, you cannot apply the rule if there's addition or subtraction. So if it said x to the third plus y to the fifth, you wouldn't be able to cancel out x's. But right here you can. So you could, if you wanted to, expand x, x, x for the top 3. On the bottom x, you need 7. you know, that's a waste of time in reality. So I'm not going to do that here. We're going to do this subtraction problem in our heads. I do want you to think of canceling in your head, though. So how many x's do we have up here? We have 3. How many do we have here? We have 7. So think about this. All of these 3 x's cancel out with 3 of these 7. How many are left? 4. And there's 4 left on the bottom. So notice I only scratched out the 7 and changed it to a 4. I completely scratched these out because there's no more x's. How about the y's? I have 5 up here. Y times y times y times y 5 times. And okay, now down here I have 7. So how many cancel out with how many? 5 cancel out with 5. How many are left? 2. So check this out. All of these 5 are going to totally cancel out. I put a line through the whole thing because all 5 cancel out with 5 of these 7, and I will have 2 left over on the bottom. You guys with me?
Wait, why not -2?
Because if you did write -2 up on top, you're going to have to change it to a positive exponent because Rule 6 says you can't have negative exponents. Right? But anyways, it's this easy. Think about how many you have on top, how many you have on the bottom, cancel it out, and see how many are left over and where they're left over. Okay? So they are left over on the bottom. It's y squared down there. Now, down here we have 3 z's, and up here we have 4 z's. So how many cancel out with how many? All 3 cancel out with all 3, or with 3 of the 4 up here, and there's only 1 left over. You guys see how I'm doing this? So what's my final answer going to be? What's left over up on top? Z to the 1, so you could just put Z. And on the bottom, what's left over? X to the 4th, Y to the 2nd, and that's it. Ladies and gentlemen, that is your answer. That is applying Rule 7. So we may know and we may understand all the rules. It gets fun when you have these types of problems that has all these different rules to apply. Okay, maybe not all 7 of them, but there's definitely a lot of them right here. Could anybody tell me any rule they think they would like to apply right now? Negative exponents, that's one rule to apply. So like, I do have a negative on the outside, and I could distribute it to each and every term. So that would be a -1. This would be a -3. This would be a +2. This would be still 0. This would be a -1 power. This would be a power of -5, power of -1, power of +2. So you could distribute that outside exponent into each and every one. That's actually Rule 3 from last week. Or you could look at the inside of the parentheses and ignore the outside for now. And you could work on the inside of the parentheses. So we could use Rule 7 of canceling out the x to the 3rd with 3 of these x's, and you'd have 2 left over, right? Or on the inside, you could move that y to the -2 down here and multiply it with the y to the 1. Or you could move this one up there, or we could apply a rule, the power of 0, that cancels out and becomes 1. So we have all these different rules that we're going to be able to apply on this one problem. Okay, so there's many roads to the same place. You guys tell me right now, which one would you like to apply first? Working on the inside of the parentheses.
Yeah, 0.
Okay, power of 0. What happens with the power of 0? Scratch it out. Done. Okay, so that z to the 0 is gone. It's not there anymore. That was one rule.
Rule
7. We want to add exponents, or what? Rule 7?
Yeah.
You want to cancel out? Yeah. Cancel out exponents? Sure, why not? Okay, so what could I cancel?
Z and Y.
There's x's that have 3 x's up on top and 5 x's on the bottom. Now, in your head, you're supposed to think, okay, x, x, x. We're not going to actually do that right here, right? And on the bottom, x, 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 right? And okay, this x cancels with that x. This x cancels with that x. But see, that's a waste of time. It's just going to be 2 left over. And where are they left over? On the bottom, right? There's 3 x's up on top. There's 5 x's on the bottom. So all of these 3 cancel out with 3 of these. There's going to be 2 left over on the bottom. Does that make sense? Okay. So far, I've applied 2 different rules. Which other rule would you like to apply? Now, you don't even have to give me the number. Just tell me, what could I do?
The one where you switch the negative on top.
Okay, the negative exponents. That's a great, okay, so let's do that one. Let's apply this negative exponent rule and move it down to the bottom, right? So that'll become y to the +2 down there. And then the z to the -2, move it up, it'll become z to the +2 up here. Now this is really getting ugly, huh? Yeah. So Once you start looking at this thing and thinking, man, this is getting ugly, stop what you're doing and rewrite what you have. Okay, so let me rewrite what I have so far. So rewriting it, I have the parenthesis, 2 on top, 3 on the bottom. The x to the 3 on top is gone. I have an x squared left over on the bottom. And the y to the negative 2, we moved it down to the bottom, so it's no longer up on top. So on the bottom, I have the y, and I have the y to the positive 2 that I just moved down. Okay? And then the z on the bottom is no longer on the bottom. I moved that z up to the top, so I have a z squared up here. Let me close the parentheses and rewrite everything. So I rewrote it. Now we could continue working. And if we look at the inside of the parentheses, we do have different rules that we could apply. Rule 1. Rule 1 says if you're multiplying y, which is really y to the 1 times y to the second, you could add those exponents, and what will it become?
Y third.
So this whole thing becomes a y to the third. And you could just put a line through it because you now have y to the third down there. So once again, let me rewrite what I have. I have parentheses. I have 2z to the second over 3x squared y to the third. And it's all to the negative 1 power. So what other rules could I apply? There's nothing else I could do on the inside. Nothing else I could do on the inside. But rule 3, distribute it to each and every term, right? And then all your exponents would be negative, right? Which means you'd have to move them all to the other side, which is fine. We could actually do that. But there's a little trick. If your exponent on the outside is negative, what you could do is change it to positive by taking your numerator and taking your denominator and switching the fraction right from the start and making that positive.
What?
Okay, maybe that shortcut is a little too much since this is the first lesson that we do. But let me distribute that outside exponent to each and every exponent on the inside and multiply. So my new answer will be 2 to the negative 1, z to the negative 2, 3 to the negative 1, x to the negative 2, y to the negative 3. Are you with me?
Yes.
And then we take all of the terms. That guy goes down, this guy goes down. In other words, everything completely flips. And it becomes positive because this negative 1 goes up, this one goes up, this one goes up. They all switch, right? So my answer will be 2 to the 1's on the bottom, 3 to the 1's on top. The x to the negative 2 that was on the bottom goes up to the top. The y to the negative 3 that was on the bottom goes up to the top. And of course, the exponents become positive. The z to the negative 2 that was up on top goes down, and it becomes z to the positive 2. And ladies and gentlemen, that is our answer. So the point that I wanted to make was I could distribute this negative exponent the way I did and then flip everything, right? Or, since I know everything could flip, the shortcut is to change it to a positive and just flip everything on the inside. You're going to end up with the same answer anyway. But anyway, this was one example of how a certain type of problem could have you apply a bunch of different rules. So for homework tonight, I want you guys to obviously watch this video, and I also want you to go through each rule and create 3 examples of your own. Okay? So rule 1, we already know rule 1 is just multiplying with the same base out of the exponents. So you guys could create that. You could do like x to the 5th times x to the 13th. What's the answer going to be? X to the 18th. That's one example for rule 1. So do 3 for each. Okay? So go through each of your rules. Rule 2, power to a power. Okay? And you could get creative if you want. So for rule 2, you could like say happy face to the 3rd power to the 5th power. Well, that'll be equal to happy face to the what? 15th power. So that's an example of rule 2. Got it? Okay.